My name is Yaarit, and I'm leading the Ceph Telemetry project. So we talked a little about telemetry today. Let's dive in. This should go this way.
There we go. That it?
Yeah, it.
All right, cool.
Awesome. So I like to look at the dictionary definition for telemetry, coming from spaceflight and telecommunication. So this is basically the science and the associated technology of the automatic recording and transmission of data from a remote source to a receiving station for analysis. Very cool for space. Why do we need that for Ceph? So as we all know, Ceph is an open source project, and we would really like to get some observability to deployments out there. So we will know how many clusters are out there, what versions they're running, to learn a bit about the storage capacity distribution, what drives they're using, what crashes are happening in those clusters, and many, many more answers that we are looking for. So developers can get real feedback from telemetry on what features are in use. We don't need to guess, we don't need to ask, we just have the data. We can learn about the version adoption rate, we can learn about the hardware that users deploy out there, new bugs. Whenever we release a point release, a major release, we can actually see new crashes reported from new clusters that adopted these versions. It helps us to prioritize those issues. We can focus on the most common issues according to the numbers of clusters that are reporting them. We can discover trends in crashes through versions. So maybe it happened just recently. Maybe we see the same crash for the last 4 versions already. And once we deliver a fix for that, we can learn if it actually works, the solution. We'll talk about it later. So for users, users can validate their deployments. They can learn what's common out there, big clusters out there, how common they are. Of course, in case they're reporting. They don't need to actively submit their crashes reports or open tickets for that. And they can use our tracking system to see similar crashes and look for solutions understand in what version those bugs are fixed. So what is our telemetry service? So it was first introduced in Mimic, and ever since we are seeing a steady opt-in community engagement. We're currently looking at 1.7 exabytes of total storage capacity coming from about 3.7 clusters with a total of 205,000 OSDs. So again, what is our telemetry? The Ceph cluster will create an anonymized and non-identifying report that contains all sorts of data about the installation, configuration, and so on. And you can all go to our public dashboards, telemetry-public.ceph.com, and see the aggregated data. So every day, the telemetry module is compiling a report from several channels and sends it to us in case you are opted in. We never send a report, we never turn the telemetry module on unless you actively opt in. The various channels, we have currently 5 different channels they can be tweaked on and or off once you opt into the service. So the first basic channel is called the basic channel. We collect some information about the various kernel and Ceph versions, the cluster size, the capacity utilization, very basic stuff about the deployment. And in case you opted in, this channel will be on by default. The other separate channel is the crash, which is also on by default. Here we collect information about the crashes that happen in the cluster. So we collect the backtrace, the assert function in case it hit, the crash was due to an assert, the condition, some basic information about the Ceph and kernel version, what daemon crashed, and so on. We then have the device channel, where it's basically the smart metrics from your devices, which is also on. And then we have a couple of other channels that are off by default. One of them is the ident channel. In case you want to identify yourself and specify contact name, email, your organization, you can do that, and some users do. And the other channel is the perf channel, where we collect a bunch of various performance counters, histograms, and so on. So how do we do that? It's important to say that our telemetry capabilities are built into Ceph. So the telemetry is a manager module. You don't need to install any extra dependencies. There isn't anything that needs to run in addition to the module. By default, home is the upstream Ceph, but if you want, you can change home to be anywhere else. So it's coming with Ceph, all these capabilities of reporting somewhere. And if you need to configure a proxy in order to report, you can also do that. Recently, we fixed the IPv6 connectivity issue that we have. So if your cluster is running on an IPv6 only environment, it can now send telemetry too. I wish Vito was in the crowd, but he knows about it, so this is really exciting. I mentioned it before, I'll mention it again. It's really important to say that by default, our telemetry reporting is off. We really respect the privacy of our users, and you need to explicitly opt into the service. You need to agree to a license for that, and you can do that via a CLI command, or you can also do that with a Ceph dashboard wizard. If you want to see the content of the report that you'll be sending us, you can either use the preview or show commands. So preview you would use in case you're not opted in. If you're already opted in, you can just use the show command, and you'll see an entire JSON with the data that is going to be shared with us. We don't contain any sensitive information in our reports. So anything like pool or host names or object names or content is out of the question. We also anonymize the reports. So we never share the FSID. We have for each cluster an anonymized ID. So we generate a specific UID for telemetry. And this is how we basically identify the same cluster that is reporting. We also redact the disk serial ID, and we never store the IPs on our backend. In case we change the data model, if we add new collections, we ask users to re-opt in. Otherwise, you keep sending the current version that you're opted into. And you can see that with the Ceph telemetry collection LS. We also send the device reports to separate endpoint than the cluster data. So this even allows for additional privacy and anonymization. So, like I mentioned, the telemetry is a manager module where the manager will aggregate the data. It will generate the cluster and the devices reports, and that daily, by default, you can configure that also to be sent in any other frequency that you like. It will send it to our endpoints. And there we have an Apache server and a Postgres database that is doing all the processing of the data. And then we have the Grafana dashboard that we'll look at in a moment. Oh, right now. So like you can see, currently we have 1.7 exabyte of total storage capacity reported. We know that there's a lot more out there in the community for, and I'd really like, hopefully at the end of this talk, to maybe try and find a solution for all these clusters that are out there that are currently not reporting and understand how we can help you help us. About 4,000 clusters out there, and we can learn that currently the most common version out there is Reef. But if we want to understand where is the majority of the storage is coming from, it's actually from Quincy. So we have breakdown by either versions and for the cluster count or versions for capacity. We can also see a breakdown by point releases. So if we look at Reef and we want to understand the adoption rate for users for point releases, we can see that most of the users are have already upgraded to 18.4, which makes us learn that it's an agile community. We adopt quickly. We're talking about the distribution of clusters according to the total capacity. So right now we can see we have some heat maps on the dashboard. The biggest clusters that are reporting are about anywhere between 32 to 64 petabytes, and currently there are 4 of these. But you can see where the red color is, this is where most of the deployments that are reporting, they're anywhere between 64 to 128 terabytes. We wanted to learn about the EC plugin out there, what's being used out there, what's most common. And we saw that easily it was JErasure. When we wanted to have further breakdown to see exactly what technique there was also very obvious. There was the Reed-Solomon technique, and this is what we say when you make your voice heard. So you share your telemetry. We learn how you use Ceph. So if we want to understand if we can build on top of that, if we can deprecate anything, this is how you vote. Dynamic dashboard to learn about capacity utilization according to storage class. So who's living on the edge? We can see that there are pretty much a lot of clusters there that are almost fully utilizing their storage. Here we're looking at the NVMe class. We can also have just a view by hard disks. So pretty similar.
You can play with that. It's on the dashboards. We were also curious about Rook. So among all of the numbers that we were seeing, how many of these are actually Rook clusters? So we can see that almost 50 petabytes of total capacity is coming from Rook, like 660 clusters. And they're mostly coming from Reef, like half and half, Reef and Squid. For the Rook developers, they can also learn about the Rook versions that are deployed, also the most popular Kubernetes versions that these clusters are running, the monitors and OSDs that are backed by PVCs, and so on. At some point, we wanted to understand who's using file store. So we had this data, and it was really nice to have a breakdown by versions. And you can see right now that for Squid, that there is no one out there that is reporting. Not surprising, right? But surprisingly enough, for Reef, there were a few clusters that are reporting, which is pretty weird. But it really helped us to understand, when we wanted to deprecate file store, how common that is. And we learned that it's pretty safe to go with this choice. And we can have surveys, we can ask users, but this gives us real insights, real-time data from your deployments. We were also curious about who's using BlueStore compression out there, and we were also surprised to find out that that was like a couple of years ago, something like that, or maybe like a year and a half ago, something like that. Yeah. So again, some of us are living on the edge. All right, let's talk about crashes. So I mentioned the crash channel. If you're opted in and you have your crash channel turned on, we will collect with the telemetry report information about the crashes that happened in your cluster. That includes a crash ID, which is a timestamp, and some random UID that we have. The backtrace, what daemon crashed, the Ceph version, some information about the operating system, some information about the assert, again, in case the crash happened due to hitting an assert. We have other information about the cluster in case you're opted into the basic channel. So we can understand whether it happened on a big cluster, or maybe it's a cluster that has a very, like the use capacity is almost 100%. It gives us some more information. We can learn about if you upgraded recently. We have more observability about the history of your cluster if you're opted into the basic channel. Just want to emphasize that logs are not being collected if you're opted into the crash channel. So having raw data is nice for the crash channel, but we need to get it in order. So at our back end, we have a crash processor that identifies the similarities among the different raw crashes. So it can group the raw crashes into signatures, and we can understand whether two raw reports that are coming from two different clusters basically represent the same issue. What's nice about the recipes of the grouping algorithm is that it supports multiple generations. So we can look at some, we have different versions of the grouping algorithm, and it allows us for backward compatibility. So if we change the algorithm, we can still identify that the crash signature is the same. And then we populate the database with this grouping information. And in addition, we have a Redmine bot that, again, having the data is nice, but we want to do something with it. So it can query the database for the most recent crash signatures, and then it will map crash signatures to Redmine issues. So in other words, it will create trackers in case it doesn't find anything similar in our tracking system. It will then populate the tracker with all sorts of relevant information, like all of the different versions that were reported for that issue. We will have a sanitized version for the backtrace that was coming from these crashes, and one example of a raw backtrace, and it will have a link to the dashboard so we can take a deeper look. So we had raw crash reports, we organized them, we mapped them to a tracker, we have a fix for them, it's merged. We can even now understand if we actually fixed the issue, or maybe we're seeing the same signature reported from newer versions. So if we fixed the issue at 18.2.3, for example, or well, 2.2, and then we're seeing that now in 18.2.4, it's not actually fixed. So we can identify any regressions. And the bot can open a new tracker and link to the original fixed issue. So we have a powerful dashboards that allows us to have very extensive search by all sorts of fields of the crashes. And it allows us also to drill down to even further cluster information that is coming from each of the clusters that reported any of these issues. And we can also see trends in crashes across different versions. So some crashes happen in different versions as well. Yes, Anton.
So those dashboards are not public.
Right, that's correct, because it's not aggregated. Yep. All right. So here, for example, we can have a breakdown by version, and we can see the blue triangle on top, rectangle, sorry, that is representing the 19.2.1 crashes. Really important to say that we see a lot of crashes. They're not all Ceph bugs. So some of them are hardware issues, some of them are environment issues, misconfiguration, problem with dependencies. So we get those too. It doesn't mean that they're Ceph bugs. So this is the dashboard that I mentioned earlier for the crashes that allows us for extensive search. We can see that there's a time frame on the right hand side. Right now, we're looking at 5 years back, but we can also look for the last day, whatever time range that we want. We can learn about the most popular signatures out there, how many times those crashes, how many times they were reported, all together and in a certain time frame, how many clusters reported them, the versions that the signature was reported from, the mapping to our tracker, and so on. Let's say that we clicked on one of the signatures. We can now see when it was first reported to us, when it was last reported, how many raw reports are there, how many clusters had this issue, the status of the tracker of the fix, and then breakdown by versions. You can see at, maybe it's not big enough, but at the bottom of the screen, we have the sanitized backtrace that we use in order to create a signature. So let's say now we're curious to see all of the other signatures that we created that hit a certain frame. So we just click, for example, here is the op tracker, and we get all of the crashes that reported this specific frame. Now we have a combination of 3 frames, which so far that was enough for us to identify similar issues. So we can also learn about the daily occurrences of these signatures, and then we have an even further view of the raw crashes. So here we have the actual report IDs. We can click on that and see all of the report, like the basic information as well, and we can click on the crash report itself to learn about the raw report and daemon versions and so on. Here we can also see the different versions of the kernel and Ceph versions that these clusters are running. So it's nice. Send us your crash reports. It helps us to monitor crashes in new releases. So we also have a few examples for trackers that were opened by the telemetry bot. They were fixed. They included some backports. The user did not have to submit any to open any tracker. None of that. There are other examples of crashes that or issues that were reported by this one is specifically by a developer, and then shout out here to Neha for checking the telemetry dashboard and looking at exactly when the issue was introduced. So I think it was reported for 16 something, and Neha saw that there are actually older reports, and this one was coming from our development. So we used the crash data to enhance our troubleshooting. Users chime in. They say, hey, I see this tracker. You know what? I have this issue too. I'm uploading logs. Maybe you can help me. Some users identify themselves. Remember the ident channel that is off by default? Sometimes we contact those users and ask them, hey, we see that your cluster reported this. Can you please help us with some logs? And shout out to you all. You always help us, so thank you. All right. This is the dashboard. Go check out the dashboard, and please turn telemetry on. And if not, we were over time, but I would really like to understand how we can find a way in the middle. So it's a win-win. So help us, help you, and vice versa. Thank you.
Yeah, so she's gonna buy drinks for everybody. So come out to the patio later and there's a question here. Yeah.
Oh.
Did you have a question?
Now, we're collecting just that part.
So you will not show the vectors, it will show some weird numbers without if it's optimized.
Oh, you mean how? So we do have the weird numbers, but when we generate the signature, we sanitize all that. So this is how we can prove that easily. So we remove all sorts of numbers. Yeah, that's a good question.
Yeah, but in some cases it's it results in a code dump, we reach out to the user and say, hey, do you also have the code dump? Can you just share it with us? Because we have the version and the binaries are set, so you can inspect the code dump ourselves.
I know we're over time, so I don't want to take Dan's time, but is there any other